Hi everyone, welcome back to my channel. Today I'm gonna talk about very important process in chemical engineering, which is ion exchange. And by the end of this video, you will know about the application of ion exchange and why it's useful in our daily life. So let's get started. So, what is the ion exchange? Ion exchange is a process where ion exchange or swap between the solution and the resin. So it's a swapping process where you get out unwanted ions in a liquid with desirable ions needed in the liquid. So imagine we have a water and has magnesium plus 2, calcium plus 2, which is making hardening the water, which is make water out of specs and make you whenever you use a saw to rub your hand whatever make it very hard, so and make like a make a scum to the water. So in order to get over this process, they use a resin, and the resin is a bead and is coated with a chemical structure where the ion exchange happen on top of it. So that's just simply what the ion exchange, where the ion exchange happen between these beads or the resin and exchange and get the unwanted ions to be attached to the beads on the top of the beads and release the other ions in the solution and make it softer and clean. So let's go to the mechanism. So the mechanism, let's start with the resin structure. What's the resin structure? As I mentioned in the previous slide, is a small porous polymer, and of course has a function group. And the function group has a fixed charge, and it, of course got in the top of this beads by coating with a chemical process. And we have two types of resin exchange. The first one is cation, and the fixed function group is negative, should be negative group, and of course it holds positive ion like sodium plus sodium and hydrogen. An ion exchange is a vice versa. It has a fixed function group, positive, of course positive, and it holds a negative ion like chloride and hydroxide. And then we go to the contact with the solution, and most likely is water because it is widely used in water treatment plants and even in refineries and in utilities, in case you get rid of these ions, because in case you work in the oil and gas sector and you need the boiler for any reason, so the boiler need to get rid of for example calcium plus 2 and magnesium plus 2, because those responsible for hardening the water, and also other ions that could cause scaling on on the boiler wall, which is lower the heat transfer efficiency, which is the core of the boiler itself. So the contact with the solution when the water is passes through the resin, and most likely the resin is we put it in a container or in a column, and the water or the contaminant water or which has undesired ions is passes through the resins, so the ion exchange process happens, which is take us to the next step, the ion swap, which is the most important step in mechanism. So, for example, if we have a cation exchange, which is attached to a sodium plus, and there is a calcium plus 2 in the water. So due to the calcium has a higher affinity, which is higher attraction to the resin. So it take over the sodium plus and is attached to the resin, and the sodium released to the water solution. And the calcium is attached to the resin. And as we have in a simple equation over here, we have like a resin is attached to sodium, calcium, calcium ion plus 2, because the calcium has higher attraction force. So this is attracted to the resin, and the sodium is released to the solution, which is has no problem. And of course, the vice versa for the anion. The same thing for the anion. Um, by the time the resin gets exhaust likely saturated. So if you keep using these beads or resins for a long period of time, of course the efficiency will be lower and lower and lower and will be saturated. So for example, as we mentioned in previous example, um, the resin will be filled with a calcium plus 2. So we need to regenerate this because it will be useless. So whenever water goes through it, it will come out with the same unwanted ions without any ion exchange. So we need to do like a regeneration, which make the resin a sustainable process, and we can use it afterwards for the same process. So most likely we flush it. So for acid, the acid used for cation resin, and the base used for anion resin. And in this case, we can um, return back the sodium and sodium ions to the resin back again, um, and also make the resin is ready for reuse. That's simply the mechanism is very easy, very straightforward for anyone. And the application, let's back to application. Let's go to the application. Excuse me. So the application is used in so many, but the most common in is drinking, water purification, water plants, remove calcium, magnesium plus, which removes the hardness of the water. This is very important process, and also eliminate nitrates, sulfates, which are considered like harmful ions. Um, as I mentioned earlier, for a boiler feed water, produce DI water and prevent scaling and corrosion because ions are responsible for corrosion of equipment. So we need to eliminate this from source because is gonna reduce the lifetime of equipment, and of course prevent the scaling. Scaling is very bad thing for the boiler because it lower the heat transfer, which is considered the core and everything for the boiler. If there is a scale inside, which means a boiler doesn't do its job and it's gonna need more energy in order to heat as solution or water to the desired temperature you wanted. Also, pharmaceutical used for extra ultra purification of water because this very sensitive manufacturing that we is touch everyone health. So we need to make sure that the water is meet the specs and doesn't and 100% pure, doesn't have any contaminants that could affect the meds that we are taking. Food processing, same thing. It's very sensitive manufacturing, and most likely used to remove the colors of juice and the color um, of fluids or any food. Um, to sum up this ion exchange is very simple, very vital in our life, and help us to drink clean water, to get the pure chemicals, to better product quality, and it's used in many sectors like pharmaceutical, food, stuff that touching our real life. And of course, is very handy and is very sustainable, so we can use it forever, can use it for a long period of time, as long as you do like the maintenance needed, as long as you do like a regeneration, and you flush it with acid or flush it with base, based on the type of the ion exchange you use. That's it for me, and thank you for watching, and see you in next video. Thank you so much.